Okay, so what I'm going to do in this video here today is explain what the bucket sort algorithm is, give a few examples on how that works, and give a little bit more information on runtimes and general properties of this algorithm. And so starting off, how the bucket sort algorithm works. When using a bucket sort algorithm, we're going to gather the elements and place them into groups with a range known as buckets. And then we use another sorting algorithm, or call the bucket algorithm recursively, to sort the items that have been placed in the buckets. And this approach is known as a scatter-gather algorithm because you're scattering the elements into groups, sorting them, and then gathering back together into the list. And as you can see on this image right here, it's just another explanation for the bucket sort algorithm. And then here's an example of the bucket sort algorithm with numbers. And the way this works is we have our buckets right here. Well, we have our list up top, first off. And then we have our buckets. And we have instead of just having one number, as you would in the radix sort algorithm, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you have a range of numbers. So this one holds all numbers 0 to 5. This one holds 5 to 10, 10 to 15, 15 to 20, 20 to 25. And then inside of these buckets, we call a sorting algorithm, which will sort the items in the bucket, and that'll presumably be faster because there'll be less elements in each bucket, which is why this sorting method is used. And as we can see here, there's only one. Then 8 and 9 were put in order, 11, 12, 13, 17, 19, 21, 24. So we put all of these in order, and then we gather them, which means we attach each number in order after it's been sorted from each bucket into a new list. And you can make the range of the numbers be pretty much whatever you want, whatever works best for your particular algorithm. And you could even do a radix sort if that works for you, but that's not exactly the same thing. And here's another example that I created where you can implement this the bucket sort algorithm with letters. So you can sort words by how you would see them in the dictionary. Oh, let's go back. There we are. And so you can see we have ranges that each bucket can hold. So the first one can do letters A through E, then we can do F through J, K through O, P through T, and U through Z. And we can see where each particular word is going to be going. And once we get, so this one will have 4, this one will have 3, 4, 4, 2. And then once we get all the words placed in the bucket, we'll be sorting them using either the same sorting algorithm recursively or a different one. And here we have our sorted list. And now I wanted to go over for the bucket sort algorithm, the best case, average case, and worst case scenarios. In this picture here, we have the reason why. We have some math for how we get these answers. And so the best case for the sorting algorithm is going to be O of n. And this scenario occurs when the same amount of elements are sorted into each bucket. So let's say for that previous one, we had 4 words in each bucket. That would be O of n. That would be the most efficient way to sort these. And then the average case scenario is also going to be O of n, because whether or not the algorithm has been randomly distributed through the list or not, it'll more than likely be O of n, because it'll just more than likely be O of n. And then the worst case scenario for the bucket sorting algorithm is n squared. Ugh. And this scenario occurs when certain buckets have many more elements than other buckets. So going back to our letters, if we had a lot of words that started with A, B, or C, then this could get really close to O2 because we'd have to put so much more work into this bucket than all the others, and it would just more or less be a waste of space. But yep. And then a little bit more information on the bucket sort algorithm. Is the bucket sort stable? It is stable because when you put the numbers in, they'll generally stay in the same order. And depending on what sorting system you use in here, it could be put out of order, but if you use it itself, it will be stable because it'll always keep our items in the list in order unless one is bigger than the other. And then is the bucket algorithm in place? And no, it's not considered in place because it isn't a constant amount of space because you're creating these buckets and then putting stuff back together. So it's not in place. And then here's some resources I used, and that's just about it for me.